Lesson 38, perpendicular and angle bisector of triangles. Perpendicular and angle bisectors of triangles. So, remember how we did that lesson on medians and the orthocenter and stuff?
Yep.
Yeah, we're doing more of that stuff. So every time I do this, I put a little review in there. So the median was from a vertex to the midpoint of the opposite side. And where the three medians meet is called the centroid. And then we did an altitude, which is just perpendicular from the vertex to opposite side. And where those three altitudes meet is called the orthocenter. Now we have the angle bisectors of all three vertices, all three angles in the triangle, and where those three lines meet is called the incenter. So the angle bisectors bisect each angle in the triangle. Okay. So where they meet is called the incenter. There is what's called a triangle angle bisector theorem. And basically, it says if a line bisects an angle of a triangle, then it divides the opposite side proportionally to the other two sides of the triangle. So it's easier with the picture. So if you bisect angle M, we'll call this O. Then if this is an angle bisector, which means these two angles are congruent, MN to ON is going to equal MP to OP. So it doesn't necessarily divide this side in half. It doesn't have to because we're only bisecting the angle. But this side on the left to the part of the bottom is going to be proportional to this side on the right to that part of the bottom. Yes.
So angle NOM, would that be a rectangle?
No, remember I said here, it's not, doesn't have anything to do with where it crosses or how it crosses. It's only bisecting this angle. So this doesn't have to be a right angle.
It would be.
It doesn't have to be. So
Think of like an obtuse triangle and then one of the acute angles.
So like, I was going to do an example, but my drawings are just not very good with how it looks, so I will try to do this. Okay, so we're going to bisect this angle. That still doesn't look right. Okay, so if this side is 15, and this side is 8, and that is 20, and this is X. This is A, B, D. Okay, so we want to find X. We can write a proportion. 15 over 8 will equal 20 divided by X. Then to find X, we can cross multiply. 15X equals 160, or how about I just do 20 times 8, that'll be easier. Divide by 15, then I can cancel these, make that 4, make that 3. So 32 thirds, which is 10 and 2/3. So x would be 10 and 2/3. I must have made this example up last year because it doesn't look very pretty. So if you know that, oops, I forgot to mark those or congruent, that you have an angle bisector, it will divide up the sides proportionally. That's the triangle angle bisector theorem. Okay, now the last one is a perpendicular bisector. So if you draw perpendicular bisector from every side of a triangle, the point of concurrency, which just means where they meet, is called the circumcenter. When you draw the perpendicular bisector from every side, it won't necessarily go through the vertex. In fact, most of the time I don't think it does. The circumcenter is equidistant, just means the same distance from all the vertices of the triangle. So here's an example. So if we have x, y, z, if we draw the perpendicular bisector, so this is perpendicular, cutting it in half, supposedly. And then this one is perpendicular, and this one. So this is just a rough drawing of perpendicular bisectors. Notice that they don't go through the vertices at all. But if this is the circumcenter, it's basically saying that the distance from each vertex to the circumcenter will be the same. So this will be congruent to that and that. Which means you can draw a circle, you can circumscribe a circle around the triangle. Because this would be like the radii. So you could, I'm really good at drawing, put a circle around that.
I had a question on Sage about this.
Ah, so now you know. I know a lot of questions on Sage you haven't learned yet because it's not the end of the year. But the interim is like an end of year test.
Okay.
So the circumcenter just skip a little bit, is the center of a circle which contains the 3 vertices of a triangle. So we're going to go over real quick. I think we're going over real quick. Yes, circumscribed and inscribed. So a circumscribed, we're going to just say circumscribed circle, but you can have like a circumscribed polygon also if you have a circle inside of a polygon. So a circumscribed circle is any circle that contains all the vertices of a polygon. So it doesn't have to be a triangle, it can be a square or a rectangle or any shape basically. But the circle that can go around it and all the vertices are on the circle, that's just called a circumscribed circle. And then the polygon that's inside is called a inscribed polygon. And that's just any polygon with each vertex on a circle. So just brief review with everything all together. If we draw the medians, we can, their point of concurrency is a centroid. If we draw the altitudes, it's called the orthocenter. The angle bisectors, it's going to be called the incenter. And then the perpendicular bisectors will be called the circumcenter. You'll need to refer to this often. There's a lot of questions about these. And so we just want to remember what they are. I'm putting a little mark in my notebook so that I can always find it, because I get confused about which is which. Yes.
Will we be doing a lesson practice? I'm like barely running out of page, and I'm trying to see if I should do the perpendicular circumcenter on this page or next one.
Oh, I'm not sure. I haven't decided yet. So just fit it on that page. I'm going to turn off the video now because we're done.